Hello, welcome to workshop number 1 as part of the beginner track, Rollerball Part 1. My name is Peter, and I'm joined with...
I'm Richard.
Hi, Ray.
I'm Ryan.
And so the first thing you want to do as part of this tutorial is to install Unity. If you haven't already, you can go to unity.com, download a specific version of Unity. Otherwise, you can go to Unity Hub and install Unity through Unity Hub. We're using a specific release of Unity 2020.3.15. However, it will also work if you download the recommended release. Additionally, we have all the content on our GitHub repo, which you can access here, as well as access to the slides by clicking this tiny URL link right here. And so in this tutorial, part 1, we're going to go over several goals. One is creating a scene with a ball and platforms. Second is using an input system to be able to move the ball and allow for jumping. Third is to write a script that moves the camera along with the ball. And the fourth is to work with colliders and scripts to prevent midair jumping and respawning when the ball falls off a platform.
Okay, so first I'm gonna go ahead and create a new scene so we can start moving around and getting used to Unity. Okay, so when you start off with a new scene, you're given just the main camera and directional lighting. But first, let's start off with the basics and start to move around. So if you want to rotate, you could hold right click and start rotating around your screen to just view everything around you. If you want to move around, you could hold right click and press WASD and start moving around like you're in a video game. If you want to move up and down, you can hold right click and press E to move up and Q to move down. If you want to move around, but you want to move faster, if you hold shift and press the WASD keys, you can move around really fast. Now, if you want to rotate around a fixed point, you can hold Alt and drag your cursor around with left click, and it'll rotate you around a point. So if you can see here, I'm moving around this camera. Okay, now if you want to zoom, you could hold Alt and drag with the right click and it zooms in and out. So you can also double click an object in the hierarchy to quickly move the camera to that scene. So if you double click to the directional light, it moves me straight out here to see the directional light. If you have a mouse with the scroll wheel, it makes it also pretty easy to zoom in and to like move around. Now talking about the scene view itself. So right here's the scene, or this tab right here is the scene view. And it really just gives you the developer view and it's everything that you can see as a developer, but not the player in the game. The game view is what the player sees. So since we have this camera pointing straight here at nothing, that's exactly what the game sees. And in the scene view, the main camera shows you a preview of what you're seeing. If you press play, it starts playing the game. So right now we're in the game view right now since we press play. Pressing pause just it takes you out of the game, but then the game's still running. You press play again, it stops the game. Now moving on to some more UI elements. Right here is the hierarchy. It's found on the left. It displays like all the game objects in a scene. Some game objects are children of other game objects, which means that they're like controlled or their parents are other game objects. And it gives it really like a hierarchy of different properties that objects can have. If you click on an object, so I'm clicking on the main camera right here, and you move on to the right, you can see the inspector. And you can see all the properties and you can change multiple properties. So if I want to change the X position of this camera right here, I could drag this around and move it left and right. You can right click and edit game objects in the hierarchy. So I can copy it and paste it. I could rename it. I could add a bunch of different objects to it. I could also just right click the hierarchy in general to create new game objects. If I want to add a 3D object like a cube, I could do it right here. And now we have a cube. Now we can move on to what is a game object?
Okay, so what is a game object? Let's create an empty game object so you can see that by default, a game object is just an empty box that contains a transform, and you can add more components to it. So this transform just represents where the game object is and how it's rotated. And you can add other components to define what this game object is. So for example, we can add a mesh to this, and we can say this is a cube mesh, as well as a mesh renderer. And now we can see that this object is now a cube. We can also add a rigid body, which adds physical properties to this game object, such as mass, drag, and whether it reacts to gravity. So basically, just a game object is like an empty box, which you can add different things to define what this game object is. And these components, besides the ones provided by Unity, like this mesh and rigid body, you can also add your own scripts. Like say we want to have a cube script, we can just create a new cube script and add it. So your scripts that you write are also components that define what this game object is. Okay, I think that's about it.
Okay, so you might be wondering, why is this cube pink? Right now, it's pink because it doesn't have a material assigned to it. So what we can do is we can either go in the inspector and select a pre-existing material, or we can create our own material. We can do that by going to the project window, right-click, create, and material. Now we have a new material. Let's name this material material, for lack of a better word. And now we have this material. We can actually drag and drop it onto our game object. And now our game object has this material under its mesh renderer. If you click material again, we can modify some of its properties, such as the shader, as well as the albedo. If you click this here, we can assign a texture map to our material. We can also change the base color by clicking the color picker and selecting the color that we want. So let's actually try to construct a level using this game object. So I'm going to change the mesh to a plane. And now you see the game object has become a plane. Let's say we want to have walls where a ball is placed, and so we can create another game object. Let's make this a cube. And we can also move it and position it. So I press R to go to the scaling tool. I can scale it down, up. Let's make it thinner. Okay. Now I can hold V to try to snap this game object to a vertice. So let me line this up. Scale it like this, right here, and snap it like that. I can also Control C, Control V to copy and paste the object, and do the same thing here, and do it one more time. I press E to go to the rotate tool. and snap it over here. And the scaling is a little bit off, so I will over here, and there we go. This will be our starting platform for the ball. Okay, so here's a quick tip for organizing level design and your project. So let's say I've created a wall like this, and I want to have all the components stored so that I don't need to just copy and paste, and I don't need to configure all these components again. So what I can do is I can take this game object, drag and drop it into the project window, and this will create a prefab. So essentially what a prefab is, it's a saved asset with all the properties that of a game object that was in the editor in the scene view. So if I have a prefab, I can just take the prefab and place it again, and we have another instance. So one thing cool about prefabs is that if you open the prefab, now you're editing the prefab. Any changes that you make to the prefab will affect other prefabs. So if I make this change, go back, you see that both prefabs were affected. So let me just undo this. So let's say I want to control or move this entire platform. What's the way I can organize this? I can create a empty game object here. I'll call this starting platform. And I can take all these game objects here. So I'm using control to select them individually. I can make these child objects of this starting platform, this empty game object. This means if I click the parent game object, I can move and the entire platform moves. All the children move accordingly, as well as I can scale it and perform other transformations.
So to create a sphere that will like use as a rolling ball, go into game objects and create a 3D object, the sphere. Now we have a sphere. And we wanted to like give player input. So just like add a component and add a player input component. And then later you can like drag the script into here. So right now you see like if you hit play, the ball is just suspended in midair. Now, since we added the rigid body component to the ball, it acts like as an physical object, and so it just like falls. Right now, we see that our ball has a rigid body component now, so it'll act as a physical object. You see, it kind of falls through the platform because the starting platform doesn't have any like colliders, so it's like not treated as something you will collide with. So right now, a mesh collider, I feel like it should be the right, mesh collider, and since it's like a plane, the mesh is shaped like a plane, so it's like exactly on top of the platform. And now the ball should just like hit the plane.
Okay, so now we have this ball that just falls down when we press play, but we need a way to control it. So we can go ahead and add a component to the sphere. We can go ahead and add a player input component. Right now we don't have any actions assigned to it, so we can go ahead and create this. We can click the create actions button. We can go into our input folder, click save, and it'll give us this default roll ball actions list. So it's general like WSD, W is up, down S, just general controls. And now that we have this, we could scroll down to our player input, drag it over, and attach it. So now we have our player input actions. So if we press play, it doesn't exactly work, and that's because we need to add a script. So if we add a new script, we can go ahead and call it player Let's call it player control. We can create and add it. So now that we have this player control script, we can edit it. So let's go ahead and edit it so that we get the player input from Unity and we could decipher it and make the ball move. So whenever you create a new script in Unity, you're given these automatically these two functions, start and update. So start is called before the first frame update. So right when the game is started and the object is active, the start function will start, and it'll just do whatever you put inside of it. And this update function is called every frame. So after every frame, it can check whether something has happened or if you want to do anything after an action has occurred. So let's go ahead and start writing some code. So let's grab some references. So we know that in our Unity game, we have rigid bodies, or we have this rigid body attached to the sphere. So we could go ahead and grab that or reference it. So we could make a private rigid body called RB. We want some movement values. So we want to figure out what direction to move in, so we can create values for that. Let's call this one moving in the X direction, private float move X, and private float move Y. Now floats they're just decimal values. Use them a lot in Unity because a lot of the time you're not going to be using integers because movement has a lot of intricacies. So floats are generally the way to go. We can grab the position of the ball. So we could go private vector 3 starting position. Now vector 3, since the ball has 3 dimensions to where it is in its location x, y, and z coordinate, it's going to be a vector 3. Now we could initialize some more variables. We could see, or we can go ahead and start defining the start function. So we want to attach the rigid body that we have defined to the ball. So we can do RB equals get component, rigid body. So this is going to grab the so this is going to grab the rigid body attached to the ball. So and let's grab the position. So starting position, transform position. Now this transform position, so you may have noticed earlier that when we're in Unity, each game object has this transform feature, and this is basically has properties of like where an object is located. So the sphere is located at position 0.67, 1.64, and negative 5.6. So it's going to grab that position when we type starting position equals transform position. Now we want to see what happens, or we want to get the ball moving on the input. So let's define a new function, void on move value, movement value. So void is just making sure that, or it's just making sure that there's no return type, and input value is the type of object or type of value we're grabbing from our input actions that we attached earlier to the sphere. So on move, we want to deal with horizontal movement. So vector 2, let's call it movement vector. Set that equal to movement value dot get 2. So this is going to be grabbing from the input that we attached to the sphere, the vector that in which the ball is moving, and we could set that. We can set our x and y values. Move x equals movement vector dot x, and move y equals y. Now this is basically grabbing the x movement vector from here. This is grabbing the y, and this is going to allow us to individually control where the ball is moving. So, okay, so now to get our ball moving, we have to change our update function. But first, I forgot something up here. We should be using UG engine system. Now, this is just going to be able to, this is the same input system I attached to the sphere earlier. So now we can actually register our inputs. So for our update function, let's go ahead and create a new vector 3. Let's call it movement equals new vector 3. Now we grab our x from movement x. We grab, and we don't want it moving in the z direction. Or since our xz, so we're moving on the xz plane, we don't want anything in the y direction really. So that's why our y is going to be 0, and we're replacing our z value with our y value since it's again in the xz plane. And I go ahead and make a comment right here just to display that. So y is the third. Okay. Now we can go ahead and we can try to get started now. I'll save this. Now this still is not working because I need to add a force component. So I can go ahead and do, or I need to add a force component to our rigid body. So we can do rb dot add force. Let's do movement times, let's see, speed. Define our speed value up here. We can make this a serializable field or serialized field. This will allow us to edit it later on in the inspector. Save this. Now we can go ahead and try it out. Okay, now we got our ball moving. As you can see, the ball is moving like extremely fast. So we can go ahead and change that in the code. So right here, we're calling update, and update's called once per frame. And that's a little too much. If our game's running at like 100 FPS, that means update's being called every single second. And we're constantly calculating, or constantly getting these new movements. And it's going to make everything move extremely fast. But if we call fixed update, it's going to be calling at a fixed rate, regardless of frame rate. And we can go ahead and try it out now. And yeah, this is a much more acceptable speed. Now I can hand it off to Richard to add some more movement components.
All right, so the next thing we can do is to add jumping to the ball. So first, let's add another field here to describe how much force to add when we're jumping. So it's another serialized field. It's also a float, and let's call it jump force. And a good number for this is 500. Okay. And let's add an onJump function so that when we press the space bar, it will jump. Okay, so in our onJump function, we can add a force. And since we're jumping, we want to add the force in the direction that's up. So we can do vector3.up, and then we can multiply this by the jump force. All right, so let's save the script. Okay, so we also need to edit the input actions to have a jump action that will call our recently written onJump function. So under this is a button type action, and we want it to be under interactions. We need to add press because we want to jump only when we press the space bar and not when we're holding the space bar. So under bindings, we can select keyboard and mouse, and also we can listen for this press the space key to bind the space key to our jump. All right, now if we save the input actions and press play, we should be able to jump by pressing the space bar. However, you might notice that we can still jump even while we're in the air, which is probably not what we want. We want to jump only when we're touching the ground. So if we stop playing the scene, we can go and click on the game object representing the ground. And here there's in the inspector, underneath the name of the game object, there's a thing called a tag. So a tag sort of is like an identifier for what kind of game object this is. And you can use this tag in your code. So if we click on this tag, right now it's untagged, we can select this ground tag. And then now from code, if we go to our script, we can use that tag to see if we're touching the ground when we're jumping. So first, let's add a private bool is grounded to represent whether our player is on the ground. And we can set it to be false at first because we're in the air at the start of the scene. Next, we need to detect when we touch the ground, we want this is grounded variable to be true. So we need to do a new function called onCollisionEnter. It's a void function. So importantly, on needs to be capitalized. Otherwise, Unity won't call this function when your ball collides with an object with a collider. Yeah, and you will use it. Unity provides us with this collision parameter, which contains information about, for example, what you collided with and how fast you were going when you were colliding, etc. So here we can do if the collision dot GameObject dot tag is equal to ground, we can set is grounded equals to true because we've touched the ground. Similarly, we need to write a function called onCollisionExit, which does the same thing, except when you stop touching the ground, we want to set is grounded to false. Okay, and finally, if we scroll down to the onJump function, we want to jump only when we're grounded. So we just add an if is grounded around this RB that had force. And now we should be able to jump only when we're touching the ground. Okay, so if we return to the scene after saving our script and press play, you can see that the ball will no longer jump when you're in midair and only jump when you're on the ground. Let's play and let's jump off the platform and see what happens. As you can see, the ball just falls forever, and that's obviously not great because then the player will just be stuck underneath the platform forever. So now we should respawn the ball when it falls too far below the platform. So we can do this by creating a plane. And we want to change the scale to be quite large because you can actually jump pretty far, and we want the ball to respawn when it touches this plane. So then we also need to move the plane below the platform so that the ball respawns when it hits this plane below the platform. And we can just disable the mesh renderer to make it invisible, but it's still there. It just won't render on screen. And then under Mesh Collider, we click Convex and is trigger to make this Mesh Collider a trigger collider instead of a regular collider. So a trigger collider won't stop objects from moving through it. Instead, it will call onTriggerEnter and onTriggerExit functions in your script. So you can use this to detect when you've, for example, touched this plane and want to do something, or if you touched a pickup that you want to pick up and do something. So here we also want to add another tag so that we only respawn when we're touching tags of a certain type. So we can just add the respawn tag to this. And then now in our script, we can add the onTriggerEnter function. OnTriggerEnter is very similar to onCollisionEnter, but instead of a collision, Unity provides a collider. So, but we can still do collider.GameObject.tag equals the respawn tag. And now, if we're touching this respawn plane, we want to reset the position of the ball to the starting position. And also we want to stop the ball from moving, so we need to reset the velocity to 0. And also from spinning, so the angular velocity should also be 0. So if we save the script and go back to the game, if we jump off the platform, we should now quickly respawn on the platform.
Okay, so the last thing we want to configure is the camera so that it tracks the ball and we can follow it. Right now, the camera is a child of the sphere. And so this might be the most intuitive way, you think, to have the camera track the ball. However, since it is a child of the sphere's rotation changes as it moves. So as a result, the camera's rotation will change. And so we have to actually have the camera be a separate, not connected to the sphere that's moving. So let's create a new game object. Let's call this camera offset. This will contain a script called camera offset. Essentially, we want to position this right behind our sphere so that essentially our camera maintains the correct position offset from the ball every frame, every time it moves. So let's create the script, call it camera offset. Okay, so let's have 2 parameters. We'll have a public game object, and this will have the ball. Let's create a private vector3 and call that offset. The start position will set the offset equal to the position of the object that the script is attached to, and then we'll subtract that by the position of the ball. And so we want to use late update instead of update because the ball can move, and we want to wait for all the updates to the movement of the ball to take place before we set the position of the camera. So we can do transform.position, all.transform, and then our offset. Awesome. So we go back to Unity. We'll position right here. We'll set this to our sphere. Now we have our camera offset. Okay, so now we have a camera offset, and essentially what's going to happen if we go into the scene view, and we have this game object that's following the sphere and doesn't inherit its rotation. But we still don't have the camera tracking the ball. So what we need to do is we need to add a script to our main camera. Let's call this camera control. In this, we want to have it accept a public game object. This will be the game object of our camera target. We'll also define something called position lerp. I'll explain what that means later. Similar to the target, we want to define this as late update after all potential transformations to the ball's position have been made. And what we do is we set the position of the main character, or main camera, to vector3.lerp, transform.position, so our starting position, the position that we want to get to, which will be the target, as well as the value, which should be the lerp. So lerp means linear interpolation. Essentially, this creates a value between 2 points on a linear scale. And in this case, we use lerp so that the camera changes its position in a fixed amount of time, resulting in smooth movement. So we have to specify our camera offset, game object here, and our lerp. There you go. So some side quests. After you've finished these basic steps, you can try these things on your own. Some potential ideas are tilted platforms to allow the ball to accelerate and decelerate, moving platforms, a limited number of lives, special movement abilities, or anything else you can think of. Side quests are optional, but they're a great source of self-learning and experience points.